Thank you. And the talk has morphed a little bit since I've been in Australia, and Linda and I have been having lots of great discussions about teaching out of field and policies and practices and things like that. So the title changed a little bit as a result of those discussions. But this is a talk, the research is based on a study or a series of studies that Minda, Lopez and I are doing. And so I got the results just before I hopped on the plane to come to Australia. So this is hot off the press. Let me go back. So in looking at the impact of teaching out of field, our focus is on the impact on students. And a number of studies have shown that students show lower achievement when they are taught out of field. Klotfelter et al. Did a study in the state of North Carolina in America, and they compared in-field teaching against teachers with no licensure and found substantial differences in student learning where the test was aligned with the curriculum that was supposed to be taught. There are two additional studies that were done that looked at an American national exam where samples of students are being used, but the exam is not necessarily aligned with the curriculum that are being taught. They found that students showed higher achievement on that national exam. I know there were studies look at TIMSS and other international studies, the same kind of thing. And the problem with some of these studies is that the tests are not necessarily aligned with the curriculum that the teachers are supposed to be teaching. It's not a direct in-field versus out-of-field study, or it doesn't address prior student achievement. So in Van Overschelde 2022, in Linda and Rafaela's book that just came out earlier this year, we compared student learning for in-field versus out-of-field classes, and the tests that were used were directly aligned with the courses and the curriculum that had to be taught. We accounted for prior performance, so these are value-added models, and we did the direct comparison of in-field versus out-of-field. We looked at maths, what we call Algebra 1 and grade 8 math, grade 7 math, and what I found was that out-of-field classes led to significantly less learning, up to a third of a school year less learning when they're taught out-of-field compared to in-field. Minda and I did a subsequent study that we are in the process of finishing the manuscript for publication, where we looked at English 1 and 2, which is equivalent to grade 9 and grade 10, English, grade 7 and 8, English and reading. We found the exact same pattern of results. Students who were taught out of field experienced much less learning than students who were taught in field. So we've seen the pattern in maths, we've seen it in English, but there were some limitations in those studies. Primarily, the fact that the in-field, a teacher was classified as in-field if they had completed a teacher preparation program. So TPP is Teacher Preparation Program. So they completed a program for a particular kind of license, and they were teaching in-field based on their preparation. In Texas, you can also have a test-based license. So you can have a primary license, and then you can go and demonstrate proficiency in a new subject area or a new grade band, and we call those test-based licenses. You can also be an intern, which means you're a teacher of record, but you're still in training. You don't have a full teacher license, you have an intern license. So all three of those kinds of licenses were subsumed in the in-field category. And then we had, similarly, we had three different kinds of teachers in the out-of-field category. People who had teacher preparation-based license, but they were teaching in a different subject area. Interns who were licensed for a particular subject.
Speaker not working.
And we're teaching out of field, and then no license or no teacher preparation program. So the purpose of this study was to find out, do these different licensure pathways matter? as it relates to student learning in secondary maths. And we did it two different ways. We looked at all teachers and we looked at new teachers, and I'll explain why we broke it out that way. So the Texas is a great location for doing this kind of a quantitative study because we have a Texas Longitudinal Data System, or TLDS. We have over 30 years of student and teacher data for all 5.4 million primary and secondary students enrolled each year, and there are 400,000 teachers. We also have higher ed data and workforce data. So the TLDS has student enrollment and services received. So a student is receiving special education services, English language services, or a host of other services. We know what those services are, and we have attendance, other kinds of records like that. We can link a student and a teacher in a particular class. So we know that a student took a class third period on Monday, Wednesday, Friday, and that the size of this data set is enormous. So it's right now it's 473 million records to look at every student and every teacher, every course. We also have the state assessment data for the students in all of the core subjects, and we have a complete educator license history. So to understand the context a little bit better, in Texas, the teachers are licensed by the state. The secondary licenses are grade banded and subject specific. The primary licenses are grade banded and subject general. So you'll have core subjects, which means English, reading, math, science, social studies, or history. And the EC is early childhood through grade 6. And teachers can hold multiple licenses. So once they have their initial license, they can go back and get tested for other licenses. Licenses expire after 5 years, and there are clear rules for who is teaching in-field or out-of-field. It's over a 90-page document. So for the first study with all the teachers, we looked at Algebra 1, Grade 8 math, Grade 7 math, and you can see the number of students. These are unique students who were involved in each analysis. We classified by the teacher by the licensure type at the time the math class was taught. We used a 3-level hierarchical linear modeling with students at level 1, teachers at level 2, schools at level 3. So this is a value-added model where we accounted for prior math achievement, and we accounted for overall teaching experience, not necessarily in the teaching out of field, how many years they were teaching out of field. So what we found was that the greatest student learning happens when the class was taught by a teacher who completed a teacher preparation program for math, for secondary math. Okay. Second, a close second was the test-based license. So when a teacher completed a teacher preparation program, let's say for English, but took a test to demonstrate proficiency in math, the students in that class learned significantly less, but it was a small amount less. A distant third were students who were taught by interns and by people who had no license and no teacher preparation at all. And here we again see a 2 to 3 months of learning loss, which is equivalent to almost a third of a school year. The least amount of learning occurred when the students were taught by a licensed teacher, but that person was teaching out of field. Okay, so think about that. Some of the issues with this study, and the reason why we did the second one, is we looked at the years of teaching under the teacher-based license the years of teaching was included in the model, and that's an overall years of teaching. We did not look at the number of years that they were teaching under the test-based license. So a person could have held an English license for 10 years before they went and got their math license, and this could be their first year under the math license. So in order to account for that, we wanted to look at just the new teachers. And interns are by definition first-year teachers. So the next study was to look at only new teachers. So only students who are being taught by first-year teachers. And so then what the grouping looks like is people who completed a teacher preparation program that involves student teaching and they're teaching in field. Or teachers who completed a teacher preparation program that involves student teaching and then they went and took a test, but this is still their very first year teaching. Okay, interns teaching in field, again, their very first year, teachers, brand new teachers who are teaching out of field, and then unprepared teachers. So again, the same exact pattern. If you were prepared through a teacher preparation program, your students had the greatest amount of learning. A close second was the test-based license. A distant third were the interns and the unprepared, unlicensed folks. And the least amount of learning was when a person was teaching out of field. So these are people with a full teaching license, but they're teaching outside of their area of training. So some of the implications of these findings are that test-based licensure actually benefits students. So the testing requires professional learning in order for the teachers to pass the test. There's something in that professional learning that benefits the students of the teachers who are teaching under these test-based licenses. And it's a much better option than teaching out of field. Second, the teaching out of field should be minimized if you want to increase student learning. And third was that the internships are actually hurting student learning. So if you're looking at brand new teachers who went through a student teaching-based program versus teachers who are responsible for students, there's a huge difference in that area. So the pre-internship preparation that occurs in Texas is not sufficient for interns to be effective. So some of the follow-up studies that we're going to be doing is some of the follow-up research questions that we're going to be looking at is the impact of teaching out of field similar for interns and student teaching? So when teachers are very first responsible for students, is teaching out of field equally bad for the students? Does the number of years teaching out of field matter? So somebody who's teaching maths out of field for the very first time, do they see any benefit over time so that the effect of teaching out of field becomes less negative over time? Does the type of initial licensure matter when teaching out of field? So if you're teaching maths out of field, are there certain licenses that you received initially that are better or worse? So like Linda was talking about earlier, is English doesn't have the concept of the problem space and the misrepresentation of the problem. So is English better or worse for, if that's where your initial license is that better or worse for teaching math? And then does, the last question is, does intern effectiveness eventually catch up to the teachers who went through a student teaching based program? All right, thank you.